In this video, let's take a look at intervals of increase, decrease, and constant. So intervals of increasing, decreasing, and constant. We always want to read any graph from left to right. Increase intervals will go up as you go from left to right on the graph. Decrease intervals are going to go down, and constant intervals don't go up or down. And whenever you're naming the intervals, you want to only use X values to state the interval's start and stop points. So write those down, and then let's take a look at this example over here. So it's a great example of how going from left to right, as you go up, you're increasing. As you go down, you're decreasing. And then that can happen multiple times within one graph. And then as you flatten out or have no increase or decrease, that's called a constant interval. So take a look at that nice example and notice like where they turn around and do something different. We call those turning points on the graph. So then let's take a look at some examples that haven't already been labeled. So this says, given each function, answer the following questions. So let's do a little bit of review for a minute. So we can find our y-intercept. So I see that the y-intercept is right here at the 2. So that's my b value. And I can also find the slope. So from one point to the next, I can tell what's happening with my slope. So I'm rising 1 and I'm running 2. So my slope is 1 over 2. So it said write the equation. So I would just write 1/2 x plus 2 because I'm writing it in y equals mx plus b form. So that's just a little bit of review. Now let's pick out some good things on our graph. So it asks us to find the x-intercept. So I see the x-intercept is over here at -4 because that's our x-axis that's horizontal there. So let's put the -4, 0 was our x-intercept. The y-intercept we already found was the 2. So let's put 0, 2 was our y-intercept. We normally write those as ordered pairs because they're points on the graph. Then domain, let's review domain. So I can tell like this graph goes off the page. And when that happens, you can assume that it keeps going forever. So let's write the domain is going to go forever to the left, which is -infinity, because that's what's happening over there on the left. And then it's also going to continue to go forever to the right, which is +infinity. And remember, that's the same thing as all real numbers. Now the range of the graph, so let's take a look. The range means it's going to go, how low does it go? So this graph's going to go down forever. So we'd say -infinity again. And it's also going to continue to go up forever, which is +infinity. And again, we can also write that as all real numbers. Then let's look at the new ones, increasing, decreasing, and constant. So what I like to think about is if I was driving along in a car, that's a very fancy car, from left to right, like what's happening as I'm driving? Am I going up? Am I going down? Or am I neither going up or down? So this graph definitely looks like I'm just going to go up the whole way. So the whole entire graph is increasing. So I would say for all the x values, so from -infinity to +infinity, it's increasing. Because that should go along with what my domain was stating, because this whole graph is increasing. And we always identify the intervals with our x values. So none of the graph was decreasing and none of it was constant. So those just wouldn't apply to this graph. Now let's take a look at another example. B says we have a quadratic function. They've already written it out for us. And let's just pick out some good things about our graph. So our x-intercepts, we have 2 of them. We have one at -1 and we have one at 3. Because they've labeled that's the x-axis going sideways. And so let's write -1, 0 and 3, 0. We had 2 of them. Our y-intercept, we can see looks like it's about 1.5. So let's put 0, 1.5, because that's on the y-axis. Remember, the y-intercept always touches the vertical axis with the y-axis. Then the domain, let me try to keep my colors the same. Let's see, domain I wrote in red, so I'm going to continue that. And let's look at what's happening. As I go along this graph to the left, I can tell that like to the left, it's going to keep going technically to the left. And it gets steep and it looks like it's going down. But with domain, you don't want to ever think of up or down. You only want to think of left and right. So it's going left forever and it's going to the right forever. That's all I need to think about for my domain. So I'd say negative infinity to positive infinity, or all real numbers. But then you got to switch your thinking. You got to think of the range separately from the domain because they're opposites of each other. So this time I want to think, how far does this graph go down? So I'm only thinking of down first, and it looks like this graph goes down forever. But then it does not go up forever. It only goes up to this y value right here at 2. So we would say the range would be negative infinity, since it did go down and it keeps going off the page, so we assume it keeps going down. And then it went up to 2, and it's equal to 2, so we need to put a bracket at 2. And just keep in mind, another way you could write that is y is less than or equal to 2 is the other way we write that in math. And then let's look at the new ones. We have increasing, decreasing, and constant. So again, if I'm driving along in my car from the left of this graph to the right, I want to think of what's happening with my car. So first, I'm definitely going uphill. And how far am I going to go uphill? I go right to this turning point. So this is a turning point for that reason. My car is literally going to turn around and do something else after that point. So I am increasing from the left, infinitely from the left, because this graph keeps going to the left. And I'm going to increase up until x equals 1. So I got to say it increases from negative infinity to 1. And the reason I'm going to put a parentheses at the 1 is because right at that 1, it's turning around and it's not increasing or decreasing, because then my car is going to go downhill, and I've got to say, well, in what interval am I going to go down or decrease? And it's going to start at 1. So that's why neither interval could claim the 1. You got to leave it so like both intervals share that 1. So it's going to decrease from 1 for x, because that's where it starts to decrease. And then it's going to decrease forever to the right. So all the way to infinity. And that would be it for that one. And then there are no constant intervals again, because there's no flat parts of the graph where it's neither increasing or decreasing. So we would just write none. All right, let's look at 2 more examples. So in this example, let's see, does this look like growth or decay? So you can imagine my little car again. Like, is it going to be going uphill and growing, or is it going to be traveling downhill? And this definitely looks like it's growth, because it's going up from left to right. And then let's start picking out all our good parts of the graph. So the x-intercept for this graph, I don't see where it actually touches the graph, and it looks like it's going to flatten out at 0 and have a horizontal asymptote. So we'd say it has no x-intercept, so none there. The y-intercept they've given us is 0, 4, since it would be hard to read if they didn't tell us what that was. And then the domain, so we can look at how far does this graph go to the left, which it looks like it's going to keep on going, because remember, if it goes off of your page like that, consider it to keep going. And then it goes to the right forever. So this domain is negative infinity to infinity, or all real numbers again. The range, however, so remember, switch your mindset to think of how low does this graph go. So it goes down, 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 and will not go down further than 0. But it's not going to equal 0 this time, because it has an asymptote right there. So we got to put a parentheses at 0. And then it will continue to go up forever. So we can put a infinity and a parentheses. Okay, so then let's think of increase, decrease, and constant. So I'm always going from the left in my car, and I'm traveling to the right. And I'm thinking of what is happening as I'm driving along. So in my car originally, I'm starting to go uphill, and I'm going to continue to go uphill the entire graph. So this entire function is increasing. So we just say that that's all the x values. So that is negative infinity to positive infinity for that interval. And therefore, there are no intervals of decrease and no intervals that are constant. Okay, let's look at one more good example. So example D is just a random graph, but we can still pick out all the good things from it. So let's practice. Our x-intercept is always on the horizontal x-axis. So that looks like it's just touching at 0. So let's just put 0, 0 for that one. The y-intercept is always on your vertical y-axis, but that looks like it's also just touching at 0, so that's okay. They can be the same value. Then we gotta look at domain. So how far does this graph go to the left? And it looks like it's going to the left, but it stops at x equals 0, and it's equal to that value. Let me erase my drawing so you can see it, because there's no reason for us to think that it would not equal 0 right there. There's not like a hole in the graph. So let's put a bracket at 0, and then it goes to the right, and it's going to continue to the right forever. So we'd put an infinity. But then you got to switch your brain to think of down and up, or lowest y values to highest y values. So if I look at the range of my graph, I go down until I get to that point again, but you got to think of that's the y value now, which is still 0, and it's still going to be equal to 0, so put a bracket. And then this graph goes up, but not forever. It only goes up to 50, and then it would equal 50, so let's put a bracket with the 50. If you wrote this with an inequality sign, you would put x is greater than or equal to 0 and also less than or equal to 50. Or excuse me, let's put the y, because we're talking about range. The y is between 0 and 50, and then it's equal to both of them. And then if you wanted to write an inequality for your domain, you could say x is greater than or equal to 0. So that's like another way you could write it. So you don't have to write it both ways unless your teacher asks you to, but it's just a good practice to know that those mean the same thing. All right, last but not least, let's look at intervals of increase, decrease, and constant. So I'm going to erase what I've got so we can just take a fresh look at the graph. And if I'm driving my car left to right, so think of what you're doing as you're driving along. So it definitely looks like I am increasing first. I'm going uphill. And you want to think of the x values of where that starts and stops on your graph. And so this one did not go off of 0. It stopped there. So it starts at x equals 0, and it will stop increasing at this point right here where x is equal to 10. So we say it increases from 0 to 10. And then after that, it looks like it just stayed flat. So my car is not going to increase or decrease after that point. It's just going to be moving forward. Still left to right though. So the constant interval we'd say is going from 10 to infinity because it's got an arrow over there. So like that arrow on my graph means it's going to keep going. And then decreasing on this graph, there were no intervals of decrease. Okay, so that is it for some good examples of increasing, decreasing, and constant. And then we also reviewed some other parts of the graph.